Hello Year 9 and welcome back to another video. Today we're going to be looking at a new statistical term that helps us to describe data. So we're going to be looking at quartiles. Okay, and what quartiles are is they help us to get a better idea of a sense of how a set of data is spread out than just the range or just the median. Okay, so there's one thing before we continue that we need to make sure that we're not getting confused by. So if we were to split up a set of data into 4 parts, okay, so 4 quarters that included those datas, if you think about the scores that would actually create those divisions, there's only going to be 3 scores there, okay? So if you had if you wanted to split a whole thing into 4 parts, you would only need to split it 3 times, okay, to end up with 4 parts there. So there are actually only 3 quartiles, even though you might expect there to be 4 quartiles. Don't get it confused with quarters, okay? Let me explain what I mean by that. So we're familiar with the median, okay? And the median is the middle score that's going to split up our total data set into 2 halves. So one score that splits up our data set into 2 halves. And we call that second quartile, or Q2, okay, which is the median. And that's going to split up, like I said, the data set into 2 halves. You would kind of have the lower half and the upper half, okay? Now, there are 2 other quartiles, okay? You have Q1, okay, or the first quartile, which is going to split up the lower half into 2. So it's the middle score of the lower half of our data set. So if we're just looking at the lower half, okay, the Q1, or the first quartile, is the score that splits that lower half in 2. Okay, and then Q2, or the upper quartile, Q3, the upper quartile is the quartile that's going to split the upper half into 2. Okay, so that's the middle score of the upper half. Okay, so the median splits it into the lower half and the upper half. Q1, or the first quartile, splits the lower half into 2 again, so it's the middle score of that lower half. And then Q3, or the third quartile, is going to split the upper half into 2. So it's going to be the middle score of that upper half that has been made. Okay, so you've got 3 values here that are going to split our data into 4 parts. Okay, so 3 values, and they're called our quartiles. All right, now one more thing before we go. We can use these to find something called the interquartile range. So the interquartile range is the range between Q3 and Q1, the upper quartile minus the lower quartile. So interquartile range is Q3 minus Q1, the upper quartile minus the lower quartile. Okay, let's do a few examples to try and cement this idea in our heads so that we understand what's going on. So we've got a data set here. Here we have 7 data points, and we want to find the lower, middle, and upper quartiles to each of these scores, and then find the interquartile range. Okay. Now, the easiest one to do is actually to find the middle quartile, or the median. It's the same thing, because that's going to just be the one that's in the middle. So if we have 7 scores, they're already arranged in ascending order. The middle one, which is going to be our 4th score, is going to be our median, or our Q2, our middle quartile. So Q2 is going to equal 23 because that's our middle score. Now, if we just look at the other scores below 23, we need to split that in half here. So we've got 21, 22, and 22 again, that are our lower half scores. And we're going to split that into 2. And so the middle score of that is going to be 22 as well. So Q1 is going to be 22. And then if we look at the scores above Q2, so the upper quartile, it's going to be 25, 26, and 27. Okay, the middle one of those is 26. Okay, so you're just looking at those three scores that are above the median, and then the middle one, 26, is going to be your upper quartile. So now that we have the upper quartile, we have the lower quartile, we can find the interquartile range. So interquartile range is just going to be Q3, which is 26, minus Q1, which is 22. Okay, and the interquartile range is 4. Now, that interquartile range value is usually a better indicator of the spread than the total range. Okay, so if we take the absolute lowest score in our whole data set and the absolute lowest, our highest score, they might be outliers. They might not be typical of the rest of the data set. So you could end up with a range that doesn't really describe well most of the data. The interquartile range is usually considered a better indicator because it's not including those outliers in the score. It's just looking at how far is 50% of that data spread out. So that's why sometimes the interquartile range is used over the absolute range in describing data. Okay, let's look at another example here. So again, we're going to find the lower, middle, and upper quartiles for these scores, and then find that interquartile range again. Now this time we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So 10's an even number. If we want to find the median of an even number, we need to look at the 2 middle scores, because there's not going to be just one middle score that we can use as our median. So we're going to sort of add the middle 2 together and average them out. So add them together, divided by 2 to find the median. Let's look here. We've got 1, 2, 3, 4. Okay, and we're going to use the 5th one and the 6th score. But what do you know? They're actually the same, so we don't have to worry. We can just say that Q2 equals 5. Okay. Now, when we are doing the upper quartile and the lower quartile here, then we're going to include those 5 scores here to find the middle one. So we're going to include 3, 3, 4, 4, and 5 in our lower half, in which case the middle score is going to be 4. Okay, and for our upper quartile, we're going to use 5, 5, 6, 8, and 10, and the middle score is going to be 6. So then interquartile range is going to be 6 minus 4, which is just going to be 2 as such. Okay, so let's look at our last question here. Here we have a stem and leaf plot, and we're going to find the interquartile range for it. So just like we can read off a stem and leaf plot as if it was just a list of scores from lowest to highest, and we're going to do the same process. We're going to find these quartiles before we can then find the interquartile range. So the number of scores we have here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 scores here. Did I count that right? 3 plus 6, 9, plus 5 is 14, 18. Yeah, 23 scores here. So the middle one in 23 is going to be the 12th score. So we're going to count up to 12 to find the median, or the second middle quartile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the middle quartile is 64, okay, because that 4 there goes with the stem to make 64. And then to find Q1, we're going to have 11 scores below 64. We're going to find the middle score of those 11. So it's going to be 1, 2, 3, 4, 5, 6 is going to be our middle one. So the middle score of 11 is going to be the 6th one. So Q1, or the lower quartile, is going to be 57. Okay, to find the upper quartile, we're going to take the middle one of the 11 scores above the median. Okay, so it's going to be the 6th score above the median. So 1, 2, 3, 4, 5, 6. So our upper quartile is going to be 77. To find our interquartile range then, interquartile range, it's going to be 77, our upper quartile minus our lower quartile, which is 57, which is going to give us 20. Okay, so what we just need to be aware of is when there is an odd or an even number of cases, it can get a bit tricky. So in this example here, the median lies between those two ones because we have an even number of medians here. So we include all 5 of those in our lower as the lower half, and these 5 here above. But for this one here, we had an odd number, so we didn't have to worry about that in this case. I hope you enjoyed this video, and good luck with the questions today, and I'll see you in the next video.